All right, so we talked about hydroxy compounds, which include alcohols, and hydroxy compounds are the ones that have OH as a functional group in them. And we said that when there are alcohols, we add OL to the name, which means that you have straight chain compounds will have eth, met, prop, bute added to OL. If you have rings, then that thing similarly becomes cyclo of that thing. So, for example, four carbons in a ring, that is cyclobutanol. Okay, so one of them has OH. You can mention, if there's more than one, then of course you'll have to mention the placement. But if there's only one, then that's fine. You can just say cyclobutanol. And for example, if this was a function, this was a skeletal formula, and this is cyclobutanol. But this thing, you will have to mention where the OH are. So in this one, you can say cyclobute 1,3-ol. Again, what we are doing is we're going in a cycle, and in this case, whether you go clockwise or anti-clockwise doesn't matter, but the OH group is here. An important thing to remember whenever you're drawing these structures is that it is the O that is attached to carbon. It's not H. So when you, for example, over there I wrote OH and here I wrote HO. The HO part is telling me that it is oxygen that's attached to carbon, not OH. So if I did it like that, that is nonsensical, because first of all, it's saying that oxygen is attached to hydrogen, but where's the other bond? And secondly, it's saying that hydrogen has, for some reason, made two bonds, which will be a new thing for any hydrogen in the world. So that is uh, the way you write them, especially in these compounds. Now, this was a cyclo compound. Sometimes we get these compounds with ring in them. Okay, and these are cycles with rings in them. You can have this is a very simple compound. This is benzene. It has 6 carbons forming a ring, and then there is this circle in them. The circle is basically telling me that it has double bonds, which are like this for half the time, and they alternate, and then they're like this for half the time. So because the bonds keep on flipping, they keep on going. One carbon has a double bond with the left carbon, and then it has the one with the right carbon. Because it keeps on flipping, we say that it's better to just show it as a circle. And this circle is telling me that the bond is continuously moving, continuously flipping. And if these compounds have OH in them, then they're called phenols. Okay, so we have 3 different categories of OH groups now. We have the ones, in fact, 4 different categories. The ones that are with metal ions or water ions, they're called positive ions, they're called hydroxides. So for example, sodium hydroxide, that is sodium ion with OH as a negative ion. Then there are ones that are joined to uh, long chain carbons or straight chains, that those are called alkanols or alcohols. And we saw, for example, propanol or prop2ol and all that. Then we had the ones with cyclical compounds. So one example I just gave, cyclobutanol. So that is the cyclo part is added to the ring. And then we have the ones that have this ring in them. There is a cycle and there is a ring as well. And these are called fen is the branch thing. So phenol. So 4 different categories. Yeah.
You repeat the last one.
So whenever you have these cycles with rings in them, they work as fen. Fen is the name that we give them. Just like for 4 carbons is bute, for these as a ring, we call them fen. So this is phenol or phenol. And basically it's telling me there's alcohol part, the OH part, and there's a ring in them. The ring obviously adds a lot of new properties to OH, and we will study the structure. In fact, the properties of this ring later on in A2. But for now, we just need to focus on the alkenes, alkanols, and the cycloalkanols, or alcohols and cycloalcohols. Okay. Then we talked about that they can have function groups, and there's 2 categories of function groups which are very common. One is the function group function group isomerism. For example, instead of having O8 together, I could separate O and put it somewhere and H somewhere else. So for example, propanol, which could have been just CCC with OH on this side and fill it up with hydrogen, I could just have moved this oxygen somewhere and get ether. And this ether is simply telling me that this O was moved somewhere in the middle, which made it uh, methoxyethane or ethoxymethane. Again, its name and everything, we don't study that for now. We'll just skip it for now. Just know that this is a functional group isomer. It is not, it is an isomer, it has the same molecular formula, but it doesn't have the same functional group. Similarly, we could have positional isomers. Positional isomers are the ones in which the function group is the same, but their position changes. So for example, for propanols, this one is prop 1-ol because OH is with the first carbon. And then you could move the OH to the second carbon and get prop 2-ol. And what's happening here is that you have OH group, it is alcohol, it has the same molecular formula, but because the position has been changed, it's a positional isomer. You could obviously create more by adding branches. So that is this case in which this is a structural isomer. All of them are structural isomers. We said that they can have, they do show cis-trans isomerism or stereoisomerism based on what kind of compound they're attached to. So if there is a carbon atom with 4 different things, that will become a chiral center and show stereoisomerism. Similarly, if you have double bond and that double bond is also with OH, like carbon is there with OH, then that will also show cis-trans isomerism. So for example, in this case, let's suppose I have OH here, H here, and H here, and Cl here, for example. This compound can show cis-trans isomerism. But this compound, if I had this OH here, H, and H. Now, this compound cannot show cis-trans isomerism because both of these are the same thing. And if carbon is attached to the same things, it cannot show cis-trans isomerism. So yeah, you can have cis-trans isomerism, you can have stereoisomerism, all of them is there as long as you have the right combination or right structure. These alcohols, they have strong intermolecular forces because they can form hydrogen bond. The hydrogen and oxygen, they are in a polar bond, as you can see over here. And because of that polar bond, they can dissolve in other alcohols, they can dissolve in water, they can dissolve in carboxylic acids, they can dissolve them because they can form anything that they can form hydrogen bond with, they will, which means that they are excellent solvent. Similarly, another reaction that we saw for them in O levels was ester formation, that they formed esters. And that is simply removing a simple byproduct. So that could be water, that could be HCl, that could be ammonia. Removing a simple byproduct and joining them together, that forms ester. We will study that later on at the end of the lesson today, inshallah. Okay, so combustion was the first reaction that we talked about. All organic compounds, they can burn and they can do this. And what's happening here is that they are reacting with oxygen, and the important thing to remember is that they already have an oxygen that you can use for balancing, because balancing alcohols can be tricky sometimes, the equations of combustion. So it helps to understand that you have O in there somewhere. So those are a few examples of combustion. Then acids always react with strong metals or reactive metals by giving away H positive. Now, because in this case, in alcohols, you have OH as a polar bond, hydrogen can be given off and it can form H positive. So alcohols can act as acids sometimes. Of course, it depends on the ability of this thing. If this forms, now here's the thing, to understand why some alcohols are stronger than the other alcohols as acids, I mean, you have to understand what's happening here when this acts as an acid. So for example, if I have ethanol, so when ethanol ionizes, it forms H positive and forms C2H5O negative. This thing, C2H5O negative, is ethoxide. And this ethoxide is a negative ion. It has a lone pair, and that lone pair, it can provide to something and act as something that is a Lewis acid or base. So which one would it be? Would it be a Lewis acid or would it be a Lewis base?
Can you repeat the question?
The question is, if something has a lone pair, is it a Lewis acid or is it a Lewis base?
They're acid.
No, it's a Lewis base. Because if something can provide a lone pair, it becomes a Lewis base. And if something can accept a lone pair, that's a Lewis acid. Now, what's happening here is that alcohol split, it formed H positive, and it formed this base, this conjugate base, which is ethoxide in this case. Now, pay attention because this concept will go on till the end of A2. So it's super important that you understand this. How strongly this ethanol ionizes depends on how stable this base is. How strongly it ionizes, which means how strongly the equilibrium goes forward, depends on how stable this base is. If the base is unstable, then the equilibrium will shift backwards and alcohol will not ionize much. Very few molecules will ionize and throw to the right side, but most of them will stay in this form. But if this base is stable, then it will stay as it is and equilibrium will go forward. Now, next comes the idea that what makes this base stable and why is it that it wants to go back? So the idea is simple. It has a negative charge and a lone pair, and this is H positive with. So what can happen is the moment it ionizes, this negative charge will pull on this positive charge and form ethanol molecule again. It's pretty simple. एक पॉजिटिव है एक नेगेटिव, उन्होंने अट्रैक्ट करना है, स्नैप करना है और आपस में वापस आ जाना है, राइट? सो ये आयनाइज्ड फॉर्म में रह ही नहीं सकता if that negative charge stays there. So it all comes down to the ability of how strong this negative charge is. अगर तो ये नेगेटिव चार्ज बहुत ज्यादा है तो H पॉजिटिव वापस उससे बॉन्ड करेगा और ये वापस आ जाएगा. It will stay as molecule, it will not ionize. बट अगर ये नेगेटिव चार्ज इतना ज्यादा नहीं है, अगर ये नेगेटिव चार्ज इमेजिन करो ये डिस्ट्रीब्यूट हो जाता है या ये नेगेटिव चार्ज को कोई चीज सपोर्ट नहीं करती, then what happens कि this negative charge becomes weak and it goes backward. It does not go backward. ये इतनी strongly H positive को pull नहीं कर सकता. In what case will this negative charge be weak? Imagine if this negative charge was with something like this chlorine here. अब इस ऑक्सीजन पे नेगेटिव चार्ज है, बट साथ ही साथ ये क्लोरीन, this chlorine will also pull. It has a pulling effect on electrons. I told you that there are activating groups and there are deactivating groups, right? Activating groups are the ones that provide electrons, that make things more negative. For example, अगर ये यहाँ पर किसी इस तरह की चीज से ज्वाइन हो, so this is an activating group. It will provide electron. It has a positive inductive effect, which means it will strengthen the negative charge. उसको और negative बनाएगा. But अगर यहाँ पे कोई चीज ऐसी हो जिसकी electronegativity बहुत ज्यादा है, वो पहले ही electrons को pull कर रही है, तो this is a deactivating group. It will push the electrons towards chlorine. और उससे क्या होगा? ये ऑक्सीजन का negative charge weak हो जाएगा, क्योंकि उसके electron तो chlorine pull कर रहा है. Right? यहाँ पर this carbon, this methyl group or ethyl group will provide a positive inductive effect, जिसकी वजह से this negative charge will be strengthened. जिसका मतलब ये है कि over here if you look at ethoxide, then what's happening is the oxygen है और साथ में this ethyl group. This ethyl group is activating group. ये और negative electron बनाएगा, ये उसको push करेगा, ये उसको कहेगा तुम और negative हो जाओ. और जब ये चीज और नेगेटिव होगी तो ये इस H पॉजिटिव को ज्यादा स्ट्रांगली अट्रैक्ट करेगी, और जब वो स्ट्रांगली अट्रैक्ट करेगी तो इसको बैकवर्ड्स भेजेगी, which explains why ethanol is a very weak acid.
Sir, it's weak because the reaction keeps going
backwards. It's weak because when it ionizes, it cannot sustain the ionized position. वो आयनाइज होता है और फिर कहता है नहीं नहीं मैं नहीं होना मैं वापस जाऊं. And the reason it does that is because this oxygen is getting the positive inductive effect from this group, which makes it even more negative, which is more unstable, which allows this negative to attract this positive and bond together. Acha, understanding this idea, tell me, will methanol be a stronger acid or will ethanol be a stronger acid?
Wait, sir, can you repeat your question?
So my question is, will methanol be a stronger acid or will ethanol be a stronger acid?
So I think ethanol, because it has a larger positive inductive effect.
Excellent. Ethanol is a weaker acid. आपकी रीजन ठीक है, आपका कंक्लूजन गलत है.
Oh, okay.
Again, remember, the stronger the positive inductive effect, the stronger the negative charge, the stronger the attraction between this one and this one, which means more of equilibrium going backwards. तो एसिड रहते हैं, या इसको इस तरह समझ लो, the stronger the positive inductive effect, the greater the instability of this base. तो जब base unstable होगी, वो backwards हो जाएगी, which means it will not ionize, it will not give H positive, which means methanol is a stronger acid. Methanol can make more H positive than ethanol can. क्यों? क्योंकि मेथनॉल का जितनी स्ट्रांगली उसने बैकवर्ड जाना है वो उतना नहीं है जितना एथेनॉल का है. Ethyl has a greater inductive effect, making the base more unstable, driving the equilibrium more backwards. ठीक है? Do you understand this, everybody?
Yes, sir.
All right. So that is why they will react as acid, but with very reactive elements. Group 1 के साथ वो react करेंगे, especially sodium और पोटेशियम और उसके नीचे वालों के साथ. लिथियम के साथ भी बहुत स्लो रिएक्ट करते हैं. लिथियम का रिएक्शन वैसे हाई लेवल्स पे नहीं करते. So these are going to act as acid with sodium and form hydrogen gas, and sodium is going to come and replace the hydrogen ion and making ethoxides. Ethoxides or phenoxide or whatever. Okay. All right. So that's what happens here. And we saw a few examples of that thing happening. Doesn't matter where the OH is, it can obviously give away H positive and replace it with this. Then we talked about how you can use alcohols to make new things. And that was the primary purpose of the lesson on that day. One was you can use alcohols to make phenoxides, and these are called ethers. Okay, ethers are the compounds that have O in the middle, joining two parts. So this is an ether, ethoxide, hydroxide. Water, if it was organic, it would be an ether because water has O joining two parts together, H and H on both sides and O middle में. So वो structure होता है किसी भी ether का. तो you just have to consider water. Water में एक side पे H है, दूसरी side पे H है, बीच में O है. तो अब दोनों sides पे H की बजाय कुछ और लगा दो. So instead of having, for example, this is H, O, and H. So instead of having this, just have C2H5 with O, then CH3, and there you go. That is your ether. Okay.
There's anything with an O in the middle is an ether.
Yeah, but of course उसमें फिर आ जाता है कि are esters ethers? क्योंकि esters में भी तो हमारे पास C double O होता है और वो बीच में O आ जाता है. ठीक है?
Are they?
और are alcohol
ethers?
Sorry?
What are ethers?
Ethers are the compounds that have O in the middle of two organic compounds. So यहाँ पे भी organic चीज होगी, वहाँ पे भी organic चीज होगी और बीच में O होगा. Those are ethers. So this one is sodium ethoxide or हाँ, ठीक हो गया. अब आ जाता है कि you can use alcohols to make alkenes, and this is easy because we have already seen how alkenes can be converted to alcohols. You can make alcohol from alkene. उसकी conditions क्या थी याद है? जल्दी बताओ. Alkene, double bond, lots of negative electrons, free electron cloud. उसके अंदर हमने क्या ऐड करना है कि alcohol बन जाए?
Sir, wait, what's your question?
My question is, how do you convert alkene to alcohol?
Sir, do you add a base?
Yeah, you add a base because base will provide OH, but you also want a solvent that will help. So what's a solvent that would help?
Ethanol.
I'm sorry?
Ethanol.
Ethanol won't help because ethanol क्या करेगा? Ethanol can act as acid, बहुत weak acid, and secondly alcohol reaction में उतनी तेजी से हिस्सा नहीं लेता.
Wait, sir,
इसकी
why
वजह
do
से
we add a base to an alkene to make alcohol? Like,
yeah, तो आप alcohol ही तो बना रहे हो, so you
but like
have an
how
alkene,
have
you
lots of
want it to
negative
react with a base.
bonds?
What solvent would help? Maybe water. Water also provides OH.
Sir, but how? Oh, okay.
So having water is much cheaper than using base. Bases are made. Sodium hydroxide, for example, is difficult. It's expensive to make क्योंकि वो brine solution का electrolysis होता है और पूरा उसका एक लंबा process है. I wish we could go and see the plant in Pindatanhan. There's such a big plant और वो multi-million dollars की investment है और वो बहुत जबरदस्त plant है. I've been there. So I wish we could go and see that. तो वो सोडियम हाइड्रोक्साइड वहां पे बनता है और वो सोडियम हाइड्रोक्साइड आप रिएक्ट तो करवा रहे हो किसी भी एल्कीन के साथ, but why not just use water which is much more cheaper? It will just add to it and give us an alcohol. So in presence of sodium hydroxide helps drive the process, but water add करते जो इसके अंदर, obviously high temperature, and because alkenes can be volatile, so we heat it under reflux as well. अच्छा एक वो हो गया. Now you want to go back, so you added sodium hydroxide which was an alkali, so if you want to go back just add an acid, it will undo it, and that's what we do. We add concentrated sulfuric acid. Again alcohols volatile होते हैं, तो जब भी आपने उनको रिएक्शन करवाना है रिफ्लक्स यूज करना है. ये ज़हन में रख ले बात. Anything that's volatile, whenever you want to have a reaction, you need reflux because that will keep it from evaporating. So you take a reflux thing or whatever, ठीक है, और आप उसको ऐसे रिएक्ट करवाते हैं, alcohol pass through होता है and it converts it to alkene and water, and this is elimination reaction, because what's happening is you're removing OH from one carbon atom and hydrogen from the adjacent carbon atom. It's very important to understand कि कहाँ से hydrogen और OH निकलेंगे. So OH from one carbon and hydrogen from the adjacent carbon. अच्छा, आप अगर वो नहीं यूज करते ना, अगर आप सल्फ्यूरिक एसिड नहीं यूज करते, by the way, based on the knowledge of O levels, can you give a reason why concentrated sulfuric acid is an excellent choice? मतलब आज O level के बच्चे से जाके पूछते हैं और वो भी बता सकता है एक बात, why we should use
Hydrating agent.
Yes, very good. It's a very strong dehydrating agent. So you're technically just removing water from this. Alcohol से water निकाल दें, right? So that is why sulfuric acid is a good choice, and obviously high temperature helps. Or you could use aluminium oxide, और aluminium oxide क्या करेगा कि वो high temperature पे यही process repeat करवाएगा, वो उसको react करेगा, ठीक है? And aluminium oxide is basically ceramic के अंदर use होता है, तो हम इसको ceramic wool बोल रहे हैं और all. तो वो क्या हो रहा है, aluminium oxide है, high temperature है, alcohol उसमें से react कर रहा है और हमें हमारे पास ये setup है सारा उसका. Ethene gas is made and that we can easily collect because it's insoluble in water. It's insoluble because it cannot form a hydrogen bond with water because it's non-polar. Okay, so we did a few examples of this, how you can make this, and we know that we can make different isomers again, because if this is OH, I have to remove H from adjacent carbon. I could do it from this carbon or I could do it from this carbon. Okay, and that will give me two different isomers, and then there will be a third isomer as well, because अगर तो मैं इस carbon से hydrogen remove करता हूँ, that gives me this thing, okay, which is but1ene. Okay, straightforward, not much excitement there. But if I remove OH from here and H from here, that opens up a realm of possibilities, because now I have a double bond in something which has different groups attached. अगर मैं इस कार्बन को देखता हूँ तो इसके साथ हाइड्रोजन है और मीथाइल ग्रुप अटैच है. मैं अगर इस कार्बन को देखता हूँ, एक हाइड्रोजन चले गया, दूसरा हाइड्रोजन है और मीथाइल ग्रुप इसके साथ भी अटैच है, which means I will have cis trans isomerism. I will have a double bond in the middle and two different groups on the sides, which means I can get cis and I can get trans isomers. So this one is trans because the double bond is like that and the groups are like that. And this one is cis because the double bond is like that and the CH3 methyl groups are like that. Okay, so we have three different isomers. And of course, जब ये बन जाएंगे, we will have to do fractional distillation to separate. Okay. All right. alcohols and you can use them to make halogen alkenes. इसमें कोई क्वेश्चन तो नहीं है डिहाइड्रेटिंग या एलिमिनेशन रिएक्शन में? अच्छा, one more question. Why is this reaction called elimination and not condensation?
So because in elimination it comes from one molecule, but in condensation it comes from two different, like the water comes from two different molecules.
So yeah, that's absolutely correct. और इसी वजह से हम इसको elimination बोलते हैं, condensation. May, do you understand why that is?
Yes, sir.
Perfect. Okay, so you can use alcohols to make halogen alkenes. Again, what you have to do here is different from what you did to make alkenes. In alkenes, you needed double bond, so you removed OH. Here, you're going to replace OH. Okay, so what we'll do is we'll take OH and we'll replace it with some halogen. And how do you do that? OH, you know, it will leave as a negatively charged ion, and those are called nucleophiles. So we need another nucleophile to come in. बहुत सिंपल सी बात है, आपने हेलोजन डालना है, हेलोजन इज नेगेटिवली चार्ज, सो आप एक नेगेटिवली चार्ज रिमूव करेंगे, एंड दैट इज हाउ यू विल डू सब्स्टिट्यूशन. सब्स्टिट्यूशन का बेसिक प्रिंसिपल ही है कि जिस कैटेगरी की चीज जा रही है ना, उसी कैटेगरी की चीज आएगी. फ्री रेडिकल जा रहा है तो फ्री रेडिकल ही उसकी जगह पे आना है. सब्स्टिट्यूशन हो रही है न्यूक्लियोफाइल की, तो न्यूक्लियोफाइल ही आएगा उसकी जगह पे, इलेक्ट्रोफाइल नहीं आ सकता, जो मर्जी हो रहे. भाई नेगेटिव को नेगेटिव ही रिप्लेस करेगा, पॉजिटिव को पॉजिटिव ही रिप्लेस करेगा. सो यू आर रिमूविंग OH व्हिच इज नेगेटिव, तो कोई नेगेटिवली चार्ज चीज उसकी जगह आनी चाहिए. इसका मतलब हमें ये पता लग गया दैट द हेलोजन मस्ट हैव अ नेगेटिव चार्ज. सो इफ द हेलोजन इज नेगेटिव, तो उसके साथ कोई भी पॉजिटिव चार्ज डाल दो, कोई भी पॉजिटिव चार्ज चीज साथ में डाल दो. आप कहते हो कि मैंने एसिड यूज करना है, कर लो, H पॉजिटिव है तो परफेक्ट, गुड कॉम्बिनेशन. H पॉजिटिव पकड़ो, Br नेगेटिव पकड़ो, फॉरन आयनाइज होंगे, दे आर गुड एट आयनाइजिंग, तो व्हाई नॉट. हमें कुछ एक्स्ट्रा डालना ही नहीं पड़ेगा, क्योंकि वो खुद ही आयनाइज हो रहा है, खुद ही नेगेटिवली चार्ज पार्टिकल प्रोड्यूस कर रहा है, और हमें वो मिल रहे हैं, और हम OH को उससे रिप्लेस कर रहे हैं. अच्छा, अगर हमें कोई चीज ऐसी मिलती है जो कि खुद से आयनाइज नहीं होती, इट्स नॉट आयनाइजिंग इटसेल्फ, तो हम उसमें कोई चीज डालेंगे जो उसको आयनाइज करे, बिकॉज रिमेंबर वी नीड नेगेटिव आयंस. सो अगर ब्रोमीन ऐड करना है तो मुझे ब्रोमीन का नेगेटिव आयन चाहिए. अब मैं पकड़ के प्योर ब्रोमीन डाल देता हूँ, अब प्योर ब्रोमीन आयन बना ही नहीं सकती unless we do heterolytic fission. So that's where red phosphorus comes in. It allows us to help, it helps in doing heterolytic fission. वरना तो ये होगा कि प्योर ब्रोमीन है, ब्रोमीन नॉन पोलर मॉलिक्यूल है, वो इसके पास आएगा, थोड़ा सा टेम्परेरी डाइपोल्स जनरेट हो जाएंगे, फायदा कोई नहीं होगा. हमें उसको तोड़ना है, हमें उससे नेगेटिवली चार्ज पार्टिकल बनाना है. तो रेड फॉस्फोरस विल हेल्प अस डू दैट. एसिड में हमें इसकी जरूरत नहीं थी, क्योंकि एसिड तो खुद ही टूट रहा था. बट हियर दिस ब्रोमीन will break down, give us bromide ions, and those will come and replace OH. ठीक है. अच्छा, अगर वो भी नहीं यूज करते, हम कोई और सॉल्ट यूज कर लेते हैं, सोडियम क्लोराइड, सोडियम ब्रोमाइड, सोडियम आयोडाइड. अब हमारे पास ये सोडियम इसके साथ रिएक्ट करेगा, आयनाइज होगा, गुड. इस एथेनॉल, इस OH को रिप्लेस करने के लिए आयन मिल गया, गुड. बट भाई उस सोडियम ने उसके बाद क्या करना है, उसको भी तो सोचना है. सो दिस सोडियम, इमेजिन ये X को OH से रिप्लेस कर देते हैं हम, अब ये क्या बन जाएगा, Na. We took this ब्रोमीन और क्लोरीन और आयोडीन, और हमने इस OH की जगह उसको डाल दिया, और ये OH उसकी जगह पे आ गया. अब ये क्या चीज बन गई है,
Sodium hydroxide.
सोडियम हाइड्रोक्साइड. You have sodium hydroxide. What will that do? You don't want this thing to stay in a base for too long, because वो वापस रिवर्स कर देगी रिएक्शन को. क्योंकि इमेजिन, याद करो, in halogen alkanes we made alcohols by adding an alkali in presence of water. So अगर आप सोडियम हाइड्रोक्साइड डाल के उसको अल्कोहल बना रहे हो, तो अब ज्यादातर अल्कोहल हेलोजन एल्केन को सोडियम हाइड्रोक्साइड के साथ नहीं रख सकते. We need something to take care of that base that is being made. and that's where sulfuric acid comes in. The moment sodium hydroxide is made, वो उसके साथ reaction करता है, वो उसकी ताक में बैठा हुआ है. It reacts with it and it forms salt and water. Process safe हो गया हमारे लिए, and we get the halogen alkane that we were looking for. So everything has a purpose. और आपको वही समझना है. We did not need any extra thing here because it was ionizing on its own, not producing any harmful thing. Water बन रहा है, ठीक है, पढ़ा रहे. यहाँ पर आयनाइज नहीं हो रहा, तो रेड फॉस्फोरस डालो, आयनाइज हो जाएगा. वो आयनाइज होगा, ब्रोमाइड बनाएगा, वो इसका करेगा. गुड, हमें मिल गई चीज जो हमें चाहिए. और यहाँ पर दिस विल आयनाइज, गुड, ये उसको रिप्लेस करेगा, हमारा काम होगा. बट साथ ही साथ एक प्रॉब्लम भी है, वो बेस की तलवार उसके सर पे लटक रही होगी. वी नीड टू टेक केयर ऑफ दैट, एंड दैट्स वेयर सल्फ्यूरिक एसिड कम्स इन. उसको रिप्लेस कर देता है.
So like sulfate will then be.
Yeah, sodium sulfate will be made, which is salt, neutral salt है, कोई मसला नहीं. Because you know halogen alkanes are pretty unreactive at room temperature. तो वो जो बनेगा पड़ा रहेगा.
And so we can't have the halogen alkane and the sodium hydroxide together for too long because वरना वो फिर से alcohol बन जाएगा.
Exactly, especially if water is present. Water will help accelerate the process. तो यहाँ पे water तो होगा, salt है, उसको solvent water में तो डालना है. अच्छा, एक और challenge भी होता है उसके साथ. I don't know if we need to go into that, but अगर ज्यादा देर तक आप अल्कोहल को सोडियम हाइड्रोक्साइड के साथ रखेंगे ना, तो एलिमिनेशन होने का भी चांस होता है, क्योंकि उसने ये बनाना है और साथ ही उसने एलिमिनेट करा देना है उसको. तो वी डोंट वांट दैट. तो इस वजह से व्हाट दैट मींस इज कि याद करो, हेलोजन एल्केन्स का एक रिएक्शन हमने पढ़ा था इन विच वी वांटेड टू मेक एल्कीन्स फ्रॉम देम. ये मेरे पास हेलोजन एल्केन है, मैंने इससे ईथीन बनाना है. क्या करूं? एक साइड से Br रिमूव करूं, एक साइड से H रिमूव करूं. And how can I do that? I can do that if I have sodium hydroxide in the presence of ethanol.
Oh, okay.
So हर तरह से प्रॉब्लम है अगर हम सोडियम हाइड्रोक्साइड वहां पे रखते हैं. या तो वो इसको रिप्लेस करके एथेनॉल बना देगी, या वो इस पूरे को ही उड़ा के बाहर फेंकेगी, HBr बना देगी, and it will react with HBr itself. So both cases we don't want it to be there. All right, then we talked about how you can use alcohols to make esters, and that is where we stopped for a bit, क्योंकि इस रिएक्शन में हमारे पास मल्टीपल रीजन है और मल्टीपल ऑप्शंस है. ठीक है, एक तो बड़ी सिंपल सी ऑप्शन है. एक ऑप्शन क्या है? यू टेक अल्कोहल, यू रिएक्ट विद कार्बोक्सिलिक एसिड. क्या होगा? वी हैव स्टडीड दिस इन ओ लेवल्स. कार्बोक्सिलिक एसिड्स हैव this two groups in them. Alcohol का तो बड़ा simple है ना, alcohol has OH group in them. That's the only function group. But carboxylic acids have two function groups. एक उनमें होता है ये group, C with double bonded oxygen. This is called carbonyl. Okay, this is carbonyl. We will spend a great deal of time on carbonyls. बहुत जबरदस्त चीज है ये. And then we have OH group there, and this obviously is the hydroxy group. Okay, and when hydroxy and carbonyl are together, they form a new very useful function group जो कि carboxylic acid होता है. ठीक है, because again what happens here is कि वो OH as OH काम नहीं करना शुरू करता. मैंने अभी आपको बताया था कि H पॉजिटिव रिमूव करना डिपेंड करता है कि ये नेगेटिव चार्ज कितना स्ट्रॉन्ग है. ऐसी है ना, व्हेन दे एक्ट एज एसिड. तो एथेनॉल ऑन इट्स ओन तो इतना स्ट्रॉन्ग एसिड नहीं बन रहा था, बट कार्बोक्सिलिक एसिड बनेगा. क्यों? क्योंकि ये नेगेटिवली चार्ज है. तो अब जब ये हाइड्रोजन को लूज करने लगेगा तो ये अपने इलेक्ट्रॉन इधर पुल कर रहा होगा. कॉन्जुगेट बेस विल बी वेरी स्ट्रॉन्ग, वेरी स्टेबल, which is why carboxylic acids are good acids, stronger acids than alcohols. That's simple. Let's look at this. When this forms, this is slightly unrelated to esters, लेकिन फिर भी I'm just trying to explain कि हो क्या रहा है यहाँ पे. What happens here is that when it ionizes, it has to form these ions, right? They have to form these ions. अब ये आयन जितना स्टेबल होगा उतना ज्यादा चांस है that it will stay as it is and it will not go backwards, right? The more stable this ion, the longer it can stay as it is. Now this ion is much more stable than this one. Can you think of a reason why? Why is the ethanoate, this is ethanoate, why is ethanoate more stable base than ethoxide? Can you think of a reason?
Sir,
Ahmed?
maybe because it,
But you can make this time, right?
Yes, sir, I can.
Chalo, theek hai, good. All right. So, Meher, you were saying something.
sir, does it have something to do with the double bond of oxygen?
It has to do with oxygen, not the double bond. क्यों? Oxygen क्या कर रहा है यहाँ? Tell me, is
Is it
oxygen? Yeah, go on.
of the other oxygen?
I'm sorry.
Pulling on the electrons of the other oxygen.
Yeah, it pulls on them. Yes. It is a deactivating group, right? It pulls on the electrons. So what happens is that the electron, this negative charge, it distributed here, which makes the negative charge weak. और जितना weak negative charge होगा उतना मुश्किल होगा for it to bind with this and go back. Or in other words, जितना weak negative charge होगा, जितना weak उसकी, जितनी less उसकी concentration होगी, उतना ज्यादा chance है that it will stay as it is. In other words, the base will be more stable. The lesser the negative charge or weaker the negative charge or more its distribution, more stable the base, which means it will stay as it is and equilibrium will not go back as much. What is making this base unstable? Ethoxide is an unstable base. Why? What is in there that's making it unstable?
So the other carbon provides a positive inductive effect. So it
Yes,
makes it
it's the positive inductive effect of ethyl group. Very good. So it's an activating group, which means ये उसको और negative बनाता है, वो और negative होता है तो उतना ज़्यादा unstable होता है. But यहाँ पर it becomes less negative, which means it becomes less unstable. So it stays as it is, which is why these acids are much better acids than much stronger acids than alcohols. Okay? And that is why what happens here is that you react these things. Yeah, you react these things, and now what's going to happen is one is going to give OH, one is going to give AH, and they're going to form ester. And in this case, the ester would be, so you have COO in the middle. So obviously that is this part and then this part. So isko humne rotate karke likhna hai. So here you have this, and on that side you have this. And what is this compound called? Again, मैंने आपको बताया anything with O in the middle can be considered ether. Although ये ether की तरह react नहीं करेगा, carbonyl group है इसके अंदर. This is going to be considered a branch. The thing with oxygen. So this is the branch. So इसका नाम होगा ethyl, and that's a branch. And what about this thing? This is ethanoate. So you made an ester, and what have you removed? You removed OH from one or H from the other, or you can also think of OH here and H here. It doesn't matter. Abhi ke liye we don't need to go into कि कहाँ से H और OH आता है. The byproduct is water. Okay. So that's what alcohols do. Now here's a question that I have, and this is a little beyond your syllabus, but you guys are smart. Try to figure this out. I have ethanol here, and I react it with this compound is called ethanoyl chloride. अभी के लिए छोड़ दें इसका नाम. Try to think of the product that you'll get here.
Sir, one of them will be HCl.
Excellent. That's the byproduct. And this is again condensation reaction happening. And of course, बाकी तो आपने बहुत आसान कर दिया. If this gives H, this gives Cl, the rest of it just joins together and you get this thing. इसका नाम क्या होगा?
Ethyl ethanoate.
Excellent. Yes. ठीक है? And that's what happens here. You're getting alcohols reacting with acyl chlorides. These compounds are called acyl chlorides. ठीक है? Acyl chloride. Acyl chloride कौन सा होता है? जिसमें COCl होता है. And how is that different from anything we have seen? Not much. You just replace the OH with chloride. हमें पता है वो कैसे करते हैं. Nucleophilic substitution हो रही है. You are just taking OH away, adding Cl minus in. कोई मुश्किल काम नहीं है. अच्छा. Now along the same lines, I'm going to give you another one. What if I have and it reacted with क्या होना चाहिए?
Sir, will it make like two of these carbonyl groups?
What do you mean? Where is the other carbonyl group?
No, like one is on this and then maybe one on the cyclical.
नहीं, वहां पे कार्बोनाइल ग्रुप तो नहीं है, वहां पे तो सिंगल बॉन्ड है वो के साथ. Again, this is condensation reaction. Remove H from one, OH from the other, और बाकी को join कर दो. So here's what you get. O और बाकी COOCH3. That's it. All I did was take this thing, put it here. अब इसका नाम क्या होगा? बहुत आसान है. This is my branch. और मैंने आपको बताया था कि जब ये चीज ब्रांच में होती है इसको फेन बोलते हैं. तो फेनाइल. अगर यहाँ पे देखो ना, यहाँ पे जब ये चीज है तो इसका नाम है इथाइल, क्योंकि एथ मींस टू कार्बन एंड इट्स अ ब्रांच ऑफ YL. सो दिस थिंग इज कॉल्ड फेन. तो फेनाइल और ethanoate. Why ethanoate? Because this is my main branch and I'm getting water as a byproduct. Let's try one last time. Okay, let's try to consider that. What if I have, and I'm going a little way outside the syllabus by the way, but let's try this. Try this one. Maza aa jaye.
Sir, it'll make HCl.
Okay, yes, we will make HCl. That's right.
But I don't know how to do the other one.
You don't know how to do it, या उसका नाम नहीं आता? क्योंकि नाम नहीं आता तो कोई मसला नहीं.
No, like I don't know, like how do I make it?
बहुत सिंपल है. ये Cl उठाओ, ये Cl उठाया इधर लगा दिया, और ये जो चीज है ये उठा के इधर लगा दी. ऑफ कोर्स थोड़ा सा इसको चेंज करना पड़ेगा, मैं आपको दोबारा बनाया था नीट करने के लिए. तो आई एम कॉपिंग दिस होल थिंग. तो ये चीज पूरी कॉपी की है, यहाँ पे लगा दिया. ओके, और वो चीज को भी कॉपी करना है. तो ये ऑक्सीजन और ऑक्सीजन के साथ वामिक आई इन A1 और A2.
A1 sir.
अच्छा, ओके, आई थॉट यू वर इन A2. हाँ, तो दिस थिंग इज कॉल्ड फिनाइल बेंजोएट, बट ये नाम अभी आपके लिए छोड़ दें इसको. But do you understand the condensation process? In all of them, the similarity is that you are removing a small byproduct. अगर water remove करना है तो उसके लिए तो concentrated sulfuric acid is the best choice because it's a very strong dehydrating agent. High temperature reflux दोनों चाहिए हमें. Reflux भी चाहिए because it will evaporate otherwise. And it's removing water and forming the ester. But you can also do it with acyl chlorides or acyl bromides because they will give away HBr or HCl, some acid. Or you could do it with these compounds, and all they're doing is just doing condensation process. So it's all condensation process over and over and over again. All right, so yeah, that's it. We have seen what alcohols can do. What we haven't seen is how you make alcohols from different things, and that's deliberate. हमने हेलोजन एल्केन्स में देख लिया था, हमने एल्कीन्स में देख लिया था, एक और रह गया, बट अभी के लिए उसको हम छोड़ दें. ठीक है. So we know what alcohols can do now. There is two things left to this chapter. Okay,